How's it going, everyone? Welcome back to the channel, and today we're going to be talking about a very important metric and concept in manufacturing, which is OEE, or overall equipment effectiveness. So what it typically translates to is the performance of your facility, but it is just a starting point. It is something that you would normally gather at the very early stages of your data transformation or your data journey. And ultimately, it will show you the performance of some of your assets, and we'll get into some of the limitations. We'll also talk about the definition, because it is ultimately important to understand how OE is going to be different between different verticals, between different facilities, and ultimately equip you with better questions to ask when you're talking to your teams, when you're maybe reading some Kanban boards on your plant floor, and ultimately understand the data that is meaningful for your business and to drive ROI for your specific needs. So the three metrics are going to be performance. I'm going to write that on my board. Performance, it's going to be multiplied by availability. And last but not least, multiplied by your quality. So those three metrics are extremely important, and the discussion around OEE, at least in my conversations, is always around how do we get that information, how do we get that data, and how do we interpret that data. And what I can tell you is that, again, it is different from plant to plant, but more importantly, it is different from industry to industry. If you look at chemicals, if you look at oil and gas, if you look at home goods, or if you look at pharmaceuticals, the reality is that they're not always going to track, but also to convert the raw data into OE the same way. So it's important to understand these principles, but at the end of the day, you need to ask the questions as to how they're doing those transformations and calculations to give you the OE when you're looking at different facilities. So let's start with performance. So performance is, I don't want to say the most easy one to understand, but ultimately you have a machine that is set to run at a specific rate. And once again, this is going to be dependent on your machine. This is going to be dependent on your process, but your machine is not always going to run that set rate. For example, if I have a machine that's going to be doing 500 parts per minute, the machine is going to be slowed down for a variety of reasons. So reason number one, if you're running at lower speeds, your operator might choose to reduce the speed in order to reduce the quality defects into what we're going to get into a little bit later. But ultimately, if we're looking at 1 hour, your performance of that machine, instead of being 500 times 60 minutes, which is what you would expect, it would be 400 times the 60 minutes divided by that 500 rate. So ultimately, if you were to do a very basic calculation without anything else, you would be dividing 400 over 500, and that would be the percentage for the performance for that specific machine. Now, of course, it gets a little bit more complicated depending, again, once on how you're collecting that specific data. For example, you have ramp up periods of certain equipment. So again, if it's a high speed environment, chances are it ramps up within a couple of seconds, but a lot of times it takes a little bit of time to get up to a certain speed. I've also seen processes where there's going to be variations of depending on the process based on some of the other set points. So it's possible that the target rate for the machine is specified here, 500 parts per minute, but the reality, over a period of time, that machine never truly runs at 500. It usually runs a little bit below, so 450, 480. So your tool or your MES system should be able to calculate performance based on that exact speed. How granular it needs to be, again, depends on your equipment. And of course, we can get into those details a little bit later. Next, we have the availability. And if you've worked with systems like PackML, you will know exactly what I'm talking about here, because availability is tied to your downtime and the state of your specific equipment. The machine can be running at a specific speed, but once it is stopped, it is no longer available. It could be unavailable for a variety of reasons. If you have a machine state that is running, obviously parts are going through it if there's the raw materials present, but it could also be backed up due to downstream equipment. Is it unavailable? The answer is no, it is backed up, it is not producing, but it is available for production. So what you need to understand at the availability side is that there's going to be a little bit more nuanced than stopped or running, right? There's going to be different states, in which case the machine is still available, but it is not necessarily producing those specific parts. So I would argue, when I go to some of the sites capturing that data, if you're purely getting the counts on at the end of the packaging line, you need to do a little bit of transformation and understanding of each asset that is sequential into that specific line to understand which asset caused the actual downtime or the lack of availability. Now, of course, availability is impacted by your very standard fault codes and downtime. So if something breaks within the machine, if there is a jam caused by your parts or raw materials, it is going to be unavailable for production. So once again, you get a metric based on percentages for your availability for a specific time period. The last one we're going to look at is quality. So quality is going to be very centric to most manufacturing practices, but it's not always counted the same way as you would imagine. So for example, if you have a machine that will detect an issue with a specific object, you could have a vision system that counts that this is in fact a reject. Therefore, it's a lot easier to, for example, send that data into a system that's going to capture that count versus, for example, if you have a batch that goes through an entire cooking, ingredients, then maybe fermenting process, and then at the end there's a manual quality check that rejects the entire batch for a specific step. At that point, it becomes a little bit more difficult to track. So if you have the ability to capture the data at the machine level, where you have a specific, in most machines, you'll see a reject chute, you should have a counter that will tell you how many parts have been rejected on a basis. And again, remember that everything in terms of OEE, and more specifically MES, usually is going to be time based. So here, when I'm talking about parts per minute, the reality is an OEE reading for a minute is not going to be extremely valuable. You want to be able to make decisions over periods of time, usually, let's say, hours, shifts, days. So ultimately, your quality is going to be how many rejects have you had versus the total number of products produced, which will give you, again, a number. If you have 0 rejects, then your quality was 100%. If you have 2 rejects out of 100, that's going to leave you with 98%, so on and so forth. So you're going to be multiplying all 3 of those metrics to get the OEE for your specific machine. The very common question or discussion point that you will get into based on what I've just explained is the fact that those 3 metrics can differ depending on the type of machine you're talking about. In some machines, you have 0 rejects, so quality is always at 100%. In some machines, you have a design for validating the quality of the product that's going through. It's essentially a conveyor belt with multiple vision systems. A vision system with just a conveyor is very unlikely to go down or be unavailable or have a low performance, but it is something that will reject parts all day, every day. So you need to understand when you're talking about a specific machine and not the entire line or the entire facility, because once again, if you're just getting that number, you might be inclined to say we need to improve the performance of that specific machine, we need to improve the availability. But the reality is, like I said in the example that I've mentioned, it's actually the quality, and that machine is designed to remove bad product. And it's not necessarily that it is creating the bad product, it is simply mitigating the downstream effect of potential bad parts. So I mentioned this a couple of times already, but the next question that often comes up in my conversations is how can we collect OE? How do we get these metrics from the plant floor? Usually, and we've talked about this in a different video, you will try and get that data at the PLC and HMI layer where ultimately the raw numbers live. And a lot of times this is going to be done differently in different facilities. Some of them will elect to create specific sensor systems that will allow you to capture, let's say, the number of products produced at every stage of the process. Some of them will utilize the tags available already on the PLC side. Those could be your cycles. Those again could be the photo eyes at the exit, at the entrance, in order to understand the states. And then you're also going to tie in some of the quality and availability data. So availability a lot of times is going to be within the PLC. It's going to be your fault codes. It's going to be your state. Because like I said, the machine does not physically know whether product is going through it. It is just executing cycles. So sometimes you need to capture and synthesize both of those pieces in order to know the product is going through, cycles are going through, and the machine is putting out quality parts. And the last one, once again, so quality systems, there's going to be a lot on vision systems based, there's going to be sensors. So you should be able to tie in some of those counters from the PLC into your software on the MES layers. And when it comes to actual software, there's a lot of different options, but you can start with something very simple right off the shelf. You can get this kind of data into an HMI system. It doesn't even need to be an MES. As long as you perform the calculations, you should be able to get your OE for a specific time period. And the reason for that is because you cannot assess the performance, the availability, and the quality of your equipment reliably based on very short runs. It is possible that your machine is never going to stop during that specific hour. So when I have conversations with different plant managers or directors of operations, for example, usually the conversations go about how has the OE improved or, let's say, decreased based on weekly performance, based on monthly performance, and then you can start seeing a trend, because at that point you have enough data points to have a conversation about. The other item that I've mentioned a couple of times is that it's usually much easier and it makes a lot more sense to benchmark against the line or the facility that you're in, but also very closely related facility. For example, when I worked for a food and beverage facility that had 4 different facilities making the exact same product, that's when you can standardize on the metrics. There's going to be some nuances. If you have different equipment from different manufacturers, maybe there will be some discrepancies, but at least you're making the same product. The process should be the same, and then you can start comparing between different facilities. If you're looking at an oil and gas process and you're trying to understand as to why in a pharmaceutical based facility you're not reaching the same OE, it's going to be very difficult to justify or explain, simply because there is so much of a difference in the process and the variables. So usually you want to benchmark within the same industry, within the same facility, within the same process, and within the same product. The last conversation point that I do want to address is how often you should be pulling OEE from your equipment. And as I've explained a couple of times now, OEE is a fairly lagging indicator. There's very little you can do besides resolve the fault that you currently have on the line, reset the machines, and then start going. You obviously can resolve a deficiency in quality, for example, but that's not really going to be looking at your OE. You're going to be looking at the quality metrics on the number of rejects, and you're going to have a very different trend line, hopefully, on your machine and on your equipment to figure out some of those issues. When it comes to OE, you can be pulling data every 5 minutes. You can even store that data every hour, and usually there's not going to be a whole lot of need to be polling your PLCs or your control systems, your DCS, on a very narrow interval. And I see this mistake all the time. Again, if you're being sold a specific piece of machinery or maybe a solution that is going to be pulling that data into the cloud, you start seeing a toll on your networks. This is not going to be OE related. OE is going to be a fairly slow and steady metric that you want to collect, obviously with certain delays, but ultimately you don't need it every millisecond. And to the point that I've made earlier, you probably aren't going to look at your OE every hour and make very specific decisions. Your operators might need a Kanban board which can display the OE for the last hour, but it is usually not something that is going to be very forward looking.